So it looks like we have people trickling in. It's fine. I'll go ahead and go through my intro, and I'll probably be walking around just a little bit. How many of you guys are mobile security researchers or application security researchers in the mobile space? A few of you guys? Okay, cool. We'll go through some of the basics as far as fundamentals for Android and iOS. That way you have some sort of foundational level. And I'll be posting my slides in my Twitter here. That's my Twitter handle after my talk. So again, my name is Aaron Guzman. Twitter handle's right there. My email address, if any of you need to get a hold of me. I'm also I'm one of the contributors to the mobile security project for OWASP and the mobile testing guide that's coming out, and the mobile verification guide as well that's also coming out. Also the technical reviewer for SANS Defending Mobile Application Security Essentials, which is their Dev 531 course. Brand new, just came out a couple months ago. I'm also the board member for Los Angeles OWASP, the president for Cloud Security Alliance Southern California, and like I said, from Los Angeles. And here's a book that I was the technical editor for Practical Internet of Things Security. I like to do a lot of research in IoT because it's easy space as far as a lot of new developers who publish firmware, mobile apps, Android, iOS, web applications. So again, easy in the sense that I can find bugs faster than, let's say, more mature companies or development software companies. So here's a brief agenda. Again, we're going to go through some fundamentals. We're going to go through a lot of actually content. I'm going to try to skip through some things in the interest of time. We're going to talk about what hybrid is, some hybrid apps, some of the common findings, some demos. I'll give some demos that say on some of the recent security bugs I found in some IoT devices, but through the mobile apps. And then some of the tools that I use, and also demonstrate those tools. Free and open source, by the way. So all of these tools, you don't have to have licenses or commercial versions. They're all free, all on GitHub. They're all Python-based, oddly enough. Then we'll get to some questions in the end. So Android, most of you know, it's based off of Java, Android version of Java, or C, C++. You have the Android runtime, Dalvik VM, that converts the Java classes to Java bytecode, or to DEX bytecode. And the core components of an Android application are activities, intents, services, broadcast receivers, and content providers. And activities are basically user interfaces within an Android application. So you click through, let's say a button, shows another user interface, let's say a login page, that's one activity. An intent serves as an action. So let's say once you log in, username or password, there's an intent that authenticates the user in the back end, basically, to show the authenticated pages, for example, or activities. Services are functions or let's say actions that happen in the background that don't have user interfaces. Let's say like downloading a file would be a service within an Android application. Broadcast receiver are mostly notifications. Content providers are usually something like SQLite databases within a sandbox, within the application sandbox. And we'll go through those in a little bit and what to look for. And keep note that the activities, the services, broadcast receivers, and content providers can also be exposed to third-party applications on a device. And what that is called is exported. So if you want to have an activity available to a third-party application, you have to export that activity. So we'll go through where you define the export setting or directive to be available to a third-party application. But just know that, obviously that's going to be a risk if there's an exported or activity that, let's say, is a banking application that exports, let's say, a withdrawal page when you should only be authenticated to see it, or any other, let's say, if you're using a camera and you could view the camera feed without authenticating or bypass authentication because the activity is exported. Something to keep in mind. And again, same thing with services, broadcast receivers. You can basically drain battery life through services and broadcast receivers by, let's say doing a while loop, for example. And content providers, same thing. You're exposing the SQLite database or credential storage potentially to another third-party application. So also with Android, you have Google Bouncer, which is when you submit the applications through Google Play. Google Bouncer is basically a virtual machine that Google puts the application to basically analyze for anomalous malicious activity, vulnerable libraries, a little bit, usually like OpenSSL, they will alert the application developers. Not too much in detail as opposed to the App Store for iOS, but just keep in mind that there is some sort of baseline level security or activities that Google is or are monitoring for as far as its known malicious or backdoor behavior for Android applications. So the first place you're going to look within an Android application, when you get an Android app, you're going to look at the Android manifest.xml. And right here, you can't see it very well, but so you have an activity, and this actually, with the manifest, you define all the core components that I talked about, the activities, the services, broadcast receivers, content providers. And you also, right here, when it says activity, you also would see exported equals true if you wanted to expose that activity to a third-party application on the Android device. It's also important to note that within the Android manifest, permissions are defined. So if an application needs access to the internet, if the application needs inter-process communication to another application on the device, it would be defined within the Android manifest.xml file. Oddly enough, a lot of the configuration files in Android are XML. Even let's say not only the permissions, but when you go onto an Android device and you want to see, let's say you have an emulator or you have a rooted device, and you wanted to see every registered inter-process communication service, you would just, in the command line, if you go adb shell service space list, and you will see all the inter-process communication defined services there. So again, this is the first place you're going to look. You'll get an idea as to the attack surface, again, because you're looking at the core components of an Android application and the permissions. So the Android framework, I'm not going to go through top to bottom. I'm just going to differentiate right here from the Linux kernel, what the Android kernel is as opposed to, let's say, a regular Linux kernel, Ubuntu, Arch Linux, whatever your flavor is. So I'm going to focus on the binder for inter-process communication, as well as paranoid networking, which is not right here at the bottom, but it's all done by the heavy lifting of the kernel, the Android kernel. So as said before, so I mean, the Android, I guess, ecosystem is based upon open source libraries, right? You kind of know that already, Open Handset Alliance. And Binder is based upon Open Binder, still open source, obviously heavily modified, but there's a bit of research done here. And what Binder does is basically provides as a proxy between two processes, between a user ID and a process ID. And again, all done at the kernel level. And it checks the user ID, which is the application. And again, every time that application is installed on a device, you have a randomly generated user ID. And then you have a process ID. So acts as a proxy here, as you can see. Process A wants access to process B. And you have the binder driver, which also acts as the proxy here. And so process A is asking basically binder if it can access process B's threads. And now there is not bidirectional, but one-way communication between process A and process B, because let's say there was a permission, let's say in activity that was exported, and it was defined within the Android manifest XML. But again, it just acts as the middleman, does the heavy lifting between the user ID and the process ID. The EU ID is what the technical term is, and the process ID. And again, done by the kernel and done by Binder. And then paranoid networking. So again, paranoid networking is basically verifying that the application is in the correct group to have network capabilities, whether that be internet, IPv4, IPv6, Bluetooth. And again, also defined within the Android manifest.xml, automated wise, as far as when you install the application and the permission is it needs internet from the Android manifest. These are the proper the group IDs here. So it checks between the group IDs, and the kernel checks between the group IDs, as well as the user IDs to see if network capability is available for the application. So things to note: parallel networking, open binder, or binder for inter-process communication are two differentiators between a regular Android kernel, or Android kernel, and a Linux kernel. So we'll get back to those in a second. But as far as the Android sandbox is concerned, now I talked about when the application is installed, there's a randomly generated user ID. So in this instance, we have my app and my other app, both with two different user IDs. Now, my app wants to access my other application's sandbox, but like standard Linux, if the two user IDs aren't the same or don't have discretionary access, meaning they didn't give the other application permission, then there's no access granted. And again, standard Linux, there's nothing really fancy about Android sandboxing. It's basically Android permissions based upon discretionary access control, and not something like mandatory access control, meaning SE Linux, for example. So for Android apps, the file extensions are .apk. So you get a file, or you download an Android app. So it's app.apk. It's basically an archive file, meaning a zip file. So you can do is basically extract that, or rename that APK file to a zip file and extract it. And here are the contents of what it'll look like. Actually, Android manifest.xml. You actually have assets, the classes.dex, which is what the Dalvik VM or Android runtime, the dex bytecode, what it runs. The library folder, the meta.inf folder, which is where the developer certificate, signing certificates are at, and the resource folders are at, resource folders as well. So again, basically just a zip file, extract it. And in the dex file, this is usually where you'll have a Java decompiler, convert that to Java classes, and then use a Java decompiler or 3, which I'll show you in a little bit in the demos, depending on how it converts the Java classes from the dex bytecode to basically readable or pseudocode. Very, very easy. Takes a minute or two max, and you can even use 3, which I'll show you. There's a tool that can do 3 at one time, parallel 3 different Java decompilers. And again, the basic format of Android APK file structure. So going to the iOS side of things here, primarily based upon Objective-C, Swift, and it's a messaging language. So if you want to hook basically with GDB or some sort of runtime debugger, you would hook Objective-C message send. All applications are signed, and that's basically to let users know that it's trusted from a source such as Apple to run on the device. And the App Store review process is much more stringent. If you submit an application for Android, it'll be published the same day. If you submit an application for iOS, it'll take 2 days, sometimes even 3 days. Not that iOS reverse engineers the application or anything. They just kind of go more in depth. They require more detail as far as why an application needs access to what's called protected classes within Objective-C or iOS functions. So let's say if an application needs access to calendar data, the developer would actually have to define and write a sentence as to why they need access to that calendar data. And then also if they need access to a location all the time, they actually have to define why they need access and then where they're storing that data. And where they define that is within the info.plist here. So the equivalent to the Android manifest, the first place you're going to look in Android is Android manifest. The first place you're going to look for an iOS application is the info.plist file. They're both XML files. This is just the Xcode version here, which is the IDE for for iOS or OS X, anything basically Apple. But you can't really see because the font's too small here, but here is one of those definitions for using location. And it's basically explaining to Apple why they need the location. And this was for Kivo, which is a smart lock application. So it needs to know where your location is in order to unlock your door, lock your door, things like that. You'll also find in the info.p list other details. Sometimes you'll find API keys, and same thing with Android Manifest, whether that be for their bug crashing, their Crashalytics, sometimes even for their own custom APIs. I don't know why. It's in clear text, the XML files. And sometimes, not within info.p list, but let's go back to the Android Manifest. You'll find secret codes that say enter 1, 2, 3, 4, 5, 6 on your phone keypad. Now the application that you're using will not be pointing to production, will be pointing to staging, or start up a new menu, for example, open up a new menu in the application. They're out there, so again, first places to look. But back to the info.p list, you also find, for iOS, you have URL schemes for inter-process communication. And I believe, right here, this is actually for Domino's Pizza. I've been doing some research, I want some free pizza, so I've been looking at some pizza apps lately. But so URL schemes are a way for inter-process communication for iOS. So just like you type in http:// in the URL bar, in this case it's Domino's Pizza: / and that's how you communicate with Domino's, for example. And if another app within your iDevice wants to contact Domino's, it would just need to do the same thing: call Domino's : and then whatever directives that Domino's is taking. So let's say pizza equals, I don't know, large plus, I don't know, medium, whatever it is, it's up to the application to verify that information. And it's not explicitly said, but you can find out. There's a bunch of websites that tell you what directives URL schemes will take for, let's say, Facebook, Domino's, whatever it may be. But again, first place you're going to look, info.p list for iOS. First place you can look for Android is Android Manifest, the XML. So the app sandbox for iOS. Randomly generated home directories, and it's separated from your data containers. A little bit small, but your data containers is basically where you have your files stored, your temporary files, your cache, your library files. And while you'll have your bundler container here, which will be like your application binary, for example, let's say like your project files. Sometimes you'll find some settings files in there. They might not even be plist files or XML files. Might be straight .text files or .json files. Those are the things that you'll have to look for because no tool is going to find that. And usually you find some juicy things in there. Private keys, API keys, passwords for server-side passwords. Pretty funny, but not even joking, they'll be there. So again, for iOS application sandbox, they're just randomly generated home directories. Nothing really fancy there. And the file structure for iOS apps, and the file extension is .ipa. Same thing, they are archive files, just like .apks. You just rename them to zips, extract them, and this will be the file structure here. Every time you'll have a .payload. So even if let's say you have two apps that you want to reverse engineer, and you rename them both to .zip, and you extract them both. They'll both have the payload directory. You'll have application1.app, application2.app in the same folder. So you know, in the same folder. Other than that, so obviously right here, .app, and then here's where the application binary / and you'll find the application binary itself, and that's what you'll drop into, let's say, IDA or Hopper, to do your code review, basically, or try to get a more white box approach to it. And if you're wondering where to get, let's say, .ipa files, as a pen tester, I usually get them sent to you, but if you want to do it from a total black box perspective, let's say like I'm doing with Domino's, I'll get it from iTunes, and then I'll basically decrypt the IPA files, and then drop them into Hopper, and then there I'll go ahead and review the code. But again, from a pen tester perspective, usually just get it straight from the client, and then usually it'll be unencrypted at that point. And then again, from the file structure, you have a bunch of metadata folders here for iTunes and WatchKit as well. So who's familiar with hybrid? Hybrid frameworks or hybrid in general for mobile? Okay, not many or at all. Basically what it is iOS, the web, and Android, all on one code base, all bundled up. And there are some pros and some cons, some pretty big pros and some pretty big cons. Let's go through them here. So again, a lot of the web application aspect and the threats within web are in the hybrid ecosystem. So you have HTML5 threats, heavy JavaScript client side, meaning some developers will store secrets in JavaScript for whatever reason, or try to obfuscate their JavaScript and store secrets in there. Still, not a good idea, but something to note. And again, I said in one code base, and you'll have the web runtime as Crosswalk or WebKit, typically. And with hybrid frameworks, you'll also have their own marketplaces and plugins. So these are not governed by or regulated by the App Store or Play Store. So these are other third-party code or developers that, again, plug into your code base that are not reviewed for security, that are just, it could be me just creating a calendar JavaScript, a calendar.js, or our padding library for people to use, and no one's basically looking at it for code review for security purposes. But aside from that big, red flag, you also have, the ability to update without redeploying the application to the app stores. Because again, it's mostly web-based through the web views and heavy JavaScript, so you own that, so you can update that whenever you want. So again, big red flag there. But that's also a pro for some of these development companies because they don't want to resubmit to the App Store, wait 2 or 3 days each time. They rather just update and not have to go through that lag time. So with native, generally you have better security because you have better control and you have access to the underlying hardware for the most part. Not that you don't with hybrid, but you don't have it. You don't have, let's say, like access to the camera. Let's say for like Instagram was once hybrid, and now it's native for that purpose to have more control over the camera and editing features, for example. I'll just run through this. So with HTML5, you have WebSocket vulnerabilities, and these are real. They're in plenty of mobile applications. Local storage, this will store anything from tokens to passwords to user IDs to anything on disk that will never get deleted even when you uninstall the application. You have web workers, file system APIs to get access to the file system, WebRTC, basically for real-time communication, for chatting, for video conferencing, and even there's vulnerabilities if you do not configure WebRTC correctly. You can also scan your local network with WebRTC. So things to keep in mind. So there's even more, but the attack surface is huge, obviously, from native and mobile and just hybrid in general, even with HTML5, which is what a lot of these frameworks are based upon. So one of the most common hybrid frameworks is Cordova. Anybody heard of Cordova before, or PhoneGap? Cool. So Apache Cordova, also known as PhoneGap, again, most common. It uses Crosswalk as its web runtime for its web view. So big area for research, and I'm not going to go through all these advisories here, but just within, actually, I'm going to skip past it. This is basically, I was talking about the marketplaces, right, and the plugins. So Cordova has its own, again, marketplace. And what they define as a plugin is a package of injected code that allows the Cordova web view within which the app renders to communicate with the native platform on which it runs. To me, that sounds like cross-site scripting. I don't know. But it tells you blatantly in their documentation. And this is how you basically publish a plugin. Pretty simple, not hard. Again, probably a big area for research if it's not done already. And here's the code review process. You can't see, very small, but it's basically for code cleanliness and making sure it works and exceptions and things like that. But there's no one reviewing for code, no one reviewing for security. There's, it's governed by NPM registry. That's what they use for their package manager. So again, things to keep in mind if these types of frameworks are being deployed in your environment, or if you see them being deployed in the applications, because they're very easy to mess up. Like I said, huge attack surface. And here's the advisory page. Obviously, you can see some arrows here. And again, I'm not going to go through them all, but just within the last year, you have about 3 highs, 4 mediums, all from remote code execution to they call cross-site application scripting, but it's basically XSS. And this is both for Android and iOS. But huge area of research. It's no secret, actually. From April and May and June and July. Heavily researched. From the plugins here, you can see Cordova iOS, Android intent URLs. Here's the one. Cordova cross-application scripting. Another common hybrid framework is Xamarin. Anybody heard of Xamarin before? Cool. Xamarin is owned by Microsoft. And what they tout themselves on is anything you can do in Objective-C, Swift, or Java, you can do with C# with Xamarin. Basically, it converts C# to Java, to Objective-C, to Swift. Obviously, you're going to see some mishaps there, some issues. It's like, I'm telling 2 of my friends down there, but I have basically 2 proxies in front of me. Hey, I need to go to the restroom. Can you tell me where it's at? And they're both probably going to tell me 2 different ways, 3 different ways. But again, within these languages and these frameworks, there's obviously some issues there. But what Xamarin does, it drops their mono.NET runtime onto the devices. Like basically a DLL for Android. And there are some known advisories that we're going to get to, but something to note, that's how it runs on the devices. It also uses an executable for ARM, which is ahead of time compilation. And it has its own IDE, which is basically a fork of Visual Studio. And also has its own marketplace. So keep in mind, a huge marketplace at that, because why not? And it's open source, too. It has a commercial and a paid version. But this was funny. I was researching, just looking into Xamarin. Obviously, I know there's a huge market for it. On their front page, they show basically who their top clients are, which are the biggest companies in the world. So obviously, I'm going to look. And first place I'm going to look is their issues and their pull requests. What I find is that they have a hard-coded key store password for their authorization framework, which is xamarin.auth. And I'm not going to read through it, but basically they filed a bug back in 2014. And I went and looked, and it was still there, hard-coded, right there, as you can see. And you can see the Android account store. This is for Android, obviously, for key store. But I looked a couple months ago, and somebody was basically shocked that it still hadn't been merged into master, it still hadn't been fixed. I didn't show that. But anyway, it's still there, it's not fixed. So if there's a Xamarin app running on your device, pretty much at risk of losing your accounts for any Facebook, your Google accounts, anything like that can be exposed if your device is lost or stolen, for example. One of the known advisors here is dropping that mono DLL into the SD card of an Android device. And the SD card is world readable, world writable. So what somebody did was basically drop another DLL, backdoored that runtime library, and was able to get access to the Android device. This was back in last year in May, but it has since been fixed after Xamarin 5.1. So depending on how fast these development companies issue updates is basically dependent on how secure the clients or customers are going to be as well. So not everybody pushes code. It's not basically, and the mobile isn't equivalent to web. Not everybody pushes code 1,000 times a day. But something to keep in mind if you see Xamarin, an older version of Xamarin running. Another common framework here is a Telerik app builder, one of those drag and drop type of apps, backend as a service. And for me, when I see easy or when I hear easy, obviously I'm going to find some issues in there. So what I quickly wanted to do was go through basically their development documentation for security, and what they're telling people to do is submit their apps via their app manager rather than the App Store, Google Play Store. So when you submit your app via the App Store for iOS, it encrypts your app. I doubt that Telerik encrypts their apps. Not only that, I doubt they're like Apple and have a security team, but we won't go through all that. They're also advising, and again, look at securing a PhoneGap Cordova hybrid mobile app. They're also advising to, if you're going to put secrets into your code in JavaScript, again, obfuscate it, minify it, or load it remotely. Not great. This was all from a blog post, by the way, which had like 84 thumbs up. They have a funny disclaimer also within their documentation, basically saying that they will invoke any user-supplied data object and process regardless of whether it is trusted or not. So that makes me sad. So we'll skip through Genexus, which is basically another hybrid framework in Latin America. They have some OAuth issues. We'll just leave it at that. Basically, they hard code their OAuth client secret and ID into the Android and iOS apps. You could basically retrieve an access token forever without having a username and password. So usually, first places, if I'm testing an app, I want to be able to, well, this is probably maybe third or fourth phase. I want to be able to proxy the traffic. The first phase is obviously getting the app, decompiling it, looking for vulnerable APIs and libraries and advisories, things like that. But again, after, I want to be able to proxy that traffic. And what I'll look for in those beginning stages are if they're using vulnerable AF networking libraries, if they're using these vulnerable APIs, set any HTTPS certificate, turning SSL painting off, allow any root certificate, or allow even invalid SSL certificates. Pretty common. This is probably the most common issue I find, unless it's like a banking app, a known big bank. They'll do something like SSL pinning. But again, not as common, especially let's say with these IoT devices that I like to hack. Not a chance that they're going to be SSL pinning, or even verifying the domain or the root chain for the certificate either. And then for iOS 9 and above, by default, there's something called app transport security. Again, turn on by default, but people turn it off. And what it does is basically only allow TLS 1.2 and forward secrecy ciphers to be allowed. I don't think people are ready for that yet, but they're trying to go for a secure by default approach with Apple. But again, these usually turned off. And here's the setting in the info.plist. App transport security, allow arbitrary loads, yes, meaning allow HTTP. to be ran. Same thing with the Android side of things. Here are the vulnerable basic APIs that I look for within Java. Very, very simple. Just you can do a find, you can do a grep, whichever is easy. Once you find them, you'll basically know that the app isn't checking or turning off any hostname verification or domain or anything basically. Something to note with Cordova is that it does not support true certificate pinning. So if it's a medical application and they have a Cordova framework implemented, they're probably not implementing certificate pinning the right way or trying to do it a hacky way. But again, something to note if you're trying to support true, let's say, data confidentiality in transit. Insecure data storage is all over mobile. This is where I find all the time. You'll have encryption keys, secret keys, passwords, OAuth tokens, SQLite databases with everything from first name, last names, passwords, to Windows SIDs, to emails, email bodies. I'm not even joking. And you also have binary cookies. This is different. It's not within Android. And we'll get to binary cookies in a little bit. But here, you can't see very well, but you'll have basically a hard-coded client ID and client secret, an API key here, and a JSON file for an iOS device for a hybrid framework that was, this was, I think, Genexus hybrid framework. But it has Android settings, which you guys can see, but I'll post the slides up later. It has Android and iOS settings in here as well. The infinite facepalm. And again, here's another file, configuration file, which has their Blowfish private key here. I don't know why they were trying to roll their own crypto. But again, no-nos. Okay, I'm gonna jump to the demo in the interest of time here. More passwords, logging, access token, clear text. Here is that database I was talking about, SQLite database, username, password, hash password, everything, basically cloned from their database to a SQLite database on the device. That's exactly why though. Okay, let's get to the demo here. Okay. I'm gonna demo a tool called Mobile Security Framework. Free, open source, very, very simple to use. Based upon Python. I'm going to use Ring just because it's easy. Oh, I forgot this is a responsive. You guys can see that. So you have your activities, your services, receivers, and your providers here. But I'm just going to go through the cool parts, which is the security analysis, the code analysis here, and it basically categorizes the Java classes based upon the APIs that are being used. So if an app is storing sensitive or logging potential sensitive data, using insecure hash functions, hard-coded passwords, secrets, and keys, always a place for me to look at. So let's have a look there. I'll probably just Control F and key. Here's a key here. Oh, this is for their mix panel. Okay, nothing too crazy there, but so you get an idea. There's, you can also see how they're storing data within SQLite databases. If you can probably just search for a % sign to see if they have any dynamic queries. Probably not. But still a place for interest. Very, very easy. You can view all the Java code as well as hard-coded certificates. It could be, obviously here you have the root certificate here, place to look at. And also the URLs or API endpoints that the application is speaking to. So treasure trove of data here. Let me go back here to the top. So if I wanted to view Java, I want to search Java code here. I can also just search password. Anything that basically just says password will come up, and you'll see the pseudocode here. Obviously, you saw how fast it decompiled the app, like nothing. But there's Cork as well. And Quark was a tool built from LinkedIn, and they use, here's basically Quark. It's a Python application. It uses 3 Java decompilers. I have the report there. You can inspect the manifest. And it basically statically analyzes the app. And here are the 3 Java decompilers it uses. Once it starts up here in a second. It takes a minute. It takes about 7 minutes for it to finish up because it uses JD Core, CFR, and what is the other one? Procyon, I think is another Java decompiler. But something to note too, even with mobile security framework, you can change the Java decompilers as well that it's using. Free, open source, very, very cool. Obviously, a ton of information that you can get from an application. You don't even have to be basically an expert to know what this means. You could probably just Google your way through it afterwards and figure it out. And you're probably wondering where I got this APK. I just went to apk-dl.com, searched for Ring, verified the hash from Play Store, and what I got for the app. They're the same, not changed. And yeah, good to go from there. But for Quark, since it's doing its thing, it's search for vulnerabilities within web views, certificates, file permissions, crypto, pending intents. But just so you guys are aware, I wanted you guys to see basically the options that are out there. Not only that, for a mobile security framework, it also supports iOS applications. So if you wanted to see info.p list, you can see it as well. If you wanted to see the class information, so the classes, so you can hook during runtime analysis, you can do that. Let me just get back because I know we have a couple minutes. Pretty easy, right? Yes?
What was the name of the mobile?
Mobile security framework.
Okay, that's the analyzer?
Yeah. Mobile security framework. There's plenty out there, but those are the easiest ones. If I'm a pen tester, I have 5 days to analyze an app. I want to have the most efficiency I can to basically statically analyze, and then I can go ahead and dynamically assess the application from there. Just real quick, so you guys can have this for your research. iOS has IDB, again, free, open source. That one's based upon Ruby, so for iOS, it basically searches for a secure storage or plist files or SQLite databases. If an application is storing your password in the keychain and not within a clear text plist file. And I demonstrated Quark a little bit. MobSF is mobile security framework. Frida is a runtime analysis tool. Njarify is another Java decompiler, very, very good. And this is key, your brain. Like I was saying, those JSON files and XML files, basically being nosy is what you want to do when you're assessing these mobile applications. So trust but verify, tools don't find everything. Like I said, those JSON files, XML files, config files, those are things you have to find within the application document directories, as well as their bundler directories. So again, you can contact me. My email address, if you guys have any questions. I know I kind of ran through things fast in the interest of time, but feel free to send me a note. I'll be tweeting out my slides. Thank you.